Hello, today we are going to see some PYQ numericals of the SPCC subject. SPCC. Uh, so, here is the first numerical. The numerical is about the three address code form and while loop is used, and actually do while loop is used, and under that there is a if condition and else condition. So we have made the three address code form. In the L1, we have used the if A is less than B, go to L2. L2 means what? The if statement. And if this is false, go to L next. L next means the end of the program. And similarly, you can see this. If C is less than D, go to L3. L3 means the actual execution part. Else, go to L4. And if these conditions are done, then again go to L1 because it is a do while loop. So the next question is first and follow. It is a very simple and easy. It is asked for 5 marks. So our question is S tends to uh, big A and small a and remaining. So firstly we find the first. For first we can observe like S, here is the first letter is capital A, and then we observe A. His first letter is capital B. Then we will observe that what are the first or the initial letters of the capital B. They are B and epsilon. So similarly, we can find the first of capital S, capital A, capital B, and capital D. And the next part is finding the follow set. Follow set is the set of terminals, means small symbols without epsilons. So the first S will contain the dollar because S is not present in the right hand side. So obviously it will contain only dollar. For A, if you observe carefully, S tends to capital A and small a. So small a is following A. So thus we get the follow of A as small a. The second is B, follow of B. For follow of B, we will observe the second equation or second expression. It is A tends to capital B, capital D. So capital D is following the B. So we will observe the first of D, which is small d and epsilon. Since we don't write the epsilon, we will check the follow set of the parent of D, which is A. So the follow set of A is A. Thus we came to the conclusion that the follow set of B will be D and A. So the next question is we have to construct the three address code form for this for loop. So we will observe this for loop, and here you can see that I is equal to 0, I is less than 10, and I plus plus. We will split this. So we will initialize I is equal to 0, and in the L1 block we will reverse this condition because for loop runs for the false conditional, means till I is less than 10, but if is run for the true, means till I is greater than or equal to. That's why we reverse this condition here. Then go to L next, obviously. Then we choose this if I is less than 5, go to L2. Else part we will go to L3. L3 is what? The else part of it here. And in the L2 part, this is the if part, the main core part. Else go to L4. else go to L4. What is L4? The third condition of the for loop, I plus plus. Hence, L4 will contain I is equal to I plus 1. We had made it in a more common form. So the next question is SLR parser. So SLR parser is an example of bottom-up parser. Uh, in this, our question is S tends to in bracket S and epsilon. So here you can see I have augmented the grammar, and in the second step we have numbered the production and derived the canonical derivation by writing the dot in front of these expressions. So the third step is drawing the DFT diagram, means how the data is flowing. And in the initial stage we have just collected all the uh, expressions, and when we encounter S we go here, when we encounter opening bracket we go here. Thus you can observe this diagram and can easily solve. And the next is parsing table. Parsing table is made by writing action and go to. The action part contain the terminals. Terminals means small letters, and go to contain the capitals, means non-terminals. We will see, like for zero state we got opening bracket at 2, therefore S2. For second state we got opening bracket again at S2, thus we have written the S2. But here is one thing to observe, that here S tends to epsilon is ending. S tends to epsilon is ending. S tends to epsilon is ending. But where? It can end the it can end in the immediate next position. Thus, we are writing the reduce this shift and reduce part. We are writing the reduce part, is that R2. So we have the follow of S as end bracket and dollar. So thus we are writing in end bracket and dollar as R2 and R2. Observe R2, R2, R2 and R2 here, where S tends to epsilon is written. And similarly you can observe how I have passed this string, that is opening bracket, closing bracket, opening bracket and closing bracket, using this above table and the DFT diagram. And here is the pass tree of it. So the next question is about LL1 grammar. Uh, we need to find the first set, follow set, and in the next part we have to make the passing table. For the passing table, we have to write the non-terminal part in the left hand side and the terminals, the small letters, on the top. And we have to write from which it has been derived. So here you can see A. The A is derived. Means one more thing to focus on. We find the passing table in the LL1 grammar or the predictive grammar, uh, or the predictive parser, with the help of only first sets. So here you can see A, B and G are present. So we have find of only those. But this grammar is not, but this expression is not LL1, because here are two productions. Hence, this is not LL1. You can similarly observe this next question also. The next is LR0. LR0 is very similar to SLR, but the main change here happen is only the you can see this diagram also. So the main change occur only in this part. This part means whenever our string gets end, like I4 in the fourth state, we will we will, okay. So in the fourth stage, we will only sorry. In the fourth stage, we will write the R3 in the whole line, and in the fifth, it is handled like this. Thus, we will write R4 in the whole line. What is R3 and R4? R3 and R4 are these statements. These are ended. So the next is and here is the pass 3 of this string passed. So the drawing next is writing the phases of compiler for this statement. This is for lexical analysis, and we have derived the syntax tree out of it and generated the intermediate code. You can understand it by simply reading it. The next is DAG, that is directed acyclic graph. So here P divided by Q, P divided by Q is repeated. Thus, I have converted this directed acyclic graph in a short form. And the next, all things you can observe by own, and, and thus you can solve all these examples. I am providing this PDF in the description of this video. Thank you for watching.